The question, what ties chronic fatigue, fibromyalgia and vasculitis together? An inflammatory process, neuroinflammation, almost certainly plays a major role in the development of many neurological diseases. Andrew Lloyd has pointed out that the symptoms in chronic fatigue syndrome and fibromyalgia are brain symptoms, i.e., they are flu-like symptoms produced by the brain when we get ill. That suggests, of course, that neuroinflammatory processes are at work. Source: Overcome Fibromyalgia, Fibromyalgia 2. The areas seem to fit what we know about me/CFS. One inflamed area regulates the reticular activating system, which determines how awake or aroused one is. Several others are involved in pain sensitivity, cognitive impairment and mood. Other causes are surely possible. Younger has proposed that infection, stress, diet, trauma, etc. plus other factors have caused the microglial cells/astrocytes to become hyperactive to stimulus. The sophisticated brain imaging techniques that have been developed can do many things. Until recently, though, they've never been aimed at assessing the level of immune activity in the brain. Imaging neuroinflammation from bench to bedside. Benjamin Pulley and John W. Chen Center for Systems Biology and Department of Radiology, Massachusetts General Hospital, and Harvard Medical School, 185 Cambridge Street, Boston, Massachusetts 02114, USA. J. Clincell Immunol. 2014. 5. DOI 10.4172559,899.1000226. Adhesion molecules such as CAM1 and CD62 open the doors, so to speak, that allow immune cells to get into inflamed area. Studies suggest that magnetic resonance, MR, techniques that track adhesion molecule activity are subtle enough to detect small levels of neuroinflammation. Another technique tracks the levels of metalloproteinases, a pro-inflammatory enzyme secreted by neutrophils and monocytes in inflamed tissues. Another approach is looking at COX-1 and 2 enzyme levels. These are enzymes that convert arachidonic acid to prostaglandins, a major player in inflammation. Matrix metalloproteinases, MMPs, are substances that damage tissues in response to microglial and other immune activity. They're associated with excitotoxicity, nerve damage and gaps in the blood-brain barrier. At least 4 different markers of MMP activity are being assessed. Translocator proteins have been the most extensively studied neuroinflammation imaging technique. This technique targets a receptor that appears on activated microglial and astrocyte cells. Watanabe used the PET ligand 11-CPK-11195 to find evidence of neuroinflammation in me/CFS. In one small study, a TSPO scan picked up increased microglial activity 17 years after a group of patients had experienced a traumatic brain injury. In multiple sclerosis, this technique picked up evidence of increased microglial activation in areas of the brain that appeared normal otherwise. It's been used to assess neuroinflammation in a variety of animal models and in humans. The 11-CPK-11195 ligand that was first developed, however, had several drawbacks. It's not particularly specific, precise, and has a poor signal-to-noise ratio, and its very short half-life, 20 minutes, restricts its use. Check out the link below for a guide on long-term remission or to join in with the community.